Let's look at another example related to elections for confidence intervals. So a poll asked respondents who they would vote for in a generic ballot for the presidential election of 2020. So they basically said, would you vote for the Democratic Party candidate or Donald Trump? And this poll had 1,217 registered voters. 596 said the Democratic Party candidate. I got these numbers from a YouGov poll that was held less than about a week ago. But we have to assume this is a random sample of all voters because the different methods they use to create these polls sometimes don't lend themselves to confidence intervals. But let's assume it's a random sample and make a 99% confidence interval percent of all voters who would say the Democratic Party candidate. So calculate p hat is just your 596 over your 1217. Get about 48.9% there. Standard error of p hat, you're going to do the square root of p hat times 1 minus p hat divided by n is 1217. So that's a pretty good sample size. Your standard error ends up 1.4%. Z star for 99%. Go back and look it up. 2.576. Never be afraid to look something up if you need to refer back to it. So then the lower end, we're just going to do p hat minus z star times the standard error. And the upper end, we're going to do p hat plus z star times the standard error. So then if we report this as an interval, we could copy what we did in the last video and just put these as decimals around to one place. So 45.3 to 52.7%, like that. And then we want to interpret this interval. What does this mean? So we would say we are 99% confident that between 45.3% and 52.7% of all, and this was a survey of registered voters, would pick the Democratic Party candidate over Donald Trump. So there you go. It's an interval estimate. Here is your interval. Here's your confidence level. And you've included the context of the situation here. And if you want to, you can include the margin of error in this as well. So you can do z star times the standard error and get a margin of error of about 3.7% or so. So, of course, this is interesting, but this doesn't really tell you a lot. For one, this is a poll of registered voters. And even in the 2016 election, just over half, like little under 55% of people actually went and bothered to vote. But when you look at multiple polls together, here's a screenshot from this site, 538.com, with some recent polls. So same thing, generic ballot, you see similar things. So all the polls are essentially telling you very similar stories here in the last week of, you do this same matchup. It doesn't give all the details here, and it rounds them with no decimal places, so whatever. But they pretty much all tell you the same thing. It gets a little more interesting, though, when you look at non-generic ballots. If you look here, 538 does this thing where they rank the pollsters. Emerson College gets an A-, which means they're a very good pollster. Marquette Law School gets an AB. Some of them are so bad at polling that 538 won't even show them. It gives them an F and takes them off the site. But specific matchups are a very different story. So Trump plus 4 versus the guy whose name I'm always mispronouncing. Even with Warren, Sanders by 1, Biden loses. But all these similar polls show other numbers like this. But they differ in their methodology. Like registered voters is not the same as likely voters, which is not the same as like people who voted in 2016, for instance, which is also different than adults. And of course, this does not take into account the Electoral College or anything. So when you see poll results, just keep in mind that like one poll doesn't really tell you anything like ever. But if you want to, you can always go to aggregator sites like 538 and kind of like look at if they're all kind of saying the same thing, you can kind of think, okay, that's probably the way it is, but it might still not tell you everything you might want to know.